Welcome everyone. Today we will learn about the logistic regression. So first, make the chapter heading. Logistic regression. And today's tutorial, I will take one data set that is the hard data set. On that particular data set, we will check that a particular person has heart disease or not. Those who are interested for that data set, he or she can mail me for the data set. I'll send them that particular data set. So let's start it. First, let me import all the library as well as module. So let's start it. Import numpy as np, import pandas as pd from sklearn model selection, import train test split from sklearn linear model, import logistic regression, from sklearn dot matrix, import accuracy score. When we'll go with the logistic regression, on that scenario, we'll check the accuracy score, how much my model giving me accuracy, that things we can see. That part I will explain later. So first run this. Okay. Now I'll import that data set into the Jupyter notebook. So heart pd.read csv. Since it's a CSV file, that's why I am using read_csv. Or now let's take the path. And let's run it. Now check the heart. You will get the data set. This is the data set. Okay. If you use heart.info, it will give you the scenario of the entire data set. That means the how much rows are there, how much columns are there. At the same time, it will display every column and what are the null values, what are the data type, all those things. Okay. And now let's check, is there any null value is present there or not? If anything is null value is present there, then we have to rectify it. So first let's check it. Hard dot is null dot sum. So let's run it. Everything is 0. That means there is no null value. I'll make a separate video where I will explain if there is any null value is present. So how can you remove that thing? I'll make a separate video. So now, so this is the hard data that has been uploaded to the Jupyter notebook. Okay. Now I am just displaying once again the entire hard data set. Here you see that this is the output. Okay, and let's check that heart dot output dot value counts. So let's run it. Here total 303 values are there. Among those 303 values, 1 values are 165 and 0 are 138. That means you will get the 165 rows such that where the output is 1, and you will get 138 rows such that the output is 0. Here, if the first, let me write it. If it is 1, that indicates that that is a disease. And if it is 0, that thing indicates that's normal, no disease. Okay. So first we segregate the entire data set into two variables, that is the X and Y. And in case of Y, we'll take it as a output variable. Okay. And in case of X, I'll take the rest of the columns except output. So let's make that first. So X is equal to heart dot drop. Then which column I'll drop? The output column I'll drop. So I'll write output comma axis is equal to 1. Why I'm writing axis is equal to 1? Since we are going to drop the output, and output is a column. When you will drop anything from column format, in that case you will write axis is equal to 1, and if you drop anything from row point of view, in that case you will write 0. Since we are deleting the column, that's why I am using axis is equal to 1. So let's run it. Now check the value of X. You will get that output is not showing. That means output has been dropped, that output column. Now X. Now Y. Y, you will put that output column. That means in output, as a Y variable, you are denoting the output. That means it will give you result either 1 or it will give you result either 0. That means the disease is there or the normal people. Okay. So we will write that heart dot output. So let's run it. Now let's print it. Y. Okay. So my X variable and Y variable are set. Now I'll go for the training and testing phase. Okay. So let's first run it. Now train and test phase. Okay. So in the train and test phase, what I'll write X train, X test, Y train, Y test. That means I have divided the entire data set into two ways. That means some of the data set I am taking as a training data set, some of the data set I am taking as a testing data set. Okay. Equal to train, test, split. I have import that train, test, split earlier as well. I'm just showing that things from the sklearn.model selection. sklearn is basically a library, model selection, it's a module. From that module, I have imported train, test, split. Okay. So after that, I will use the X comma y, that means the two variables x and y, comma test size is equal to 0.1. That means the entire data set, from that entire data set, you are taking 10% data as a test data, and remaining 90% data you are taking as a training data. Okay, comma, you will use stratify. I am telling why I am using stratify. I'll tell that. Why? Stratify is equal to y. That means it may be possible that you have divided your training and testing data in such a way, I'm talking about the y variable, okay, in such a way that the entire one comes in the training set and entire 0 comes in the testing state. It may be possible. That means the testing variable, and let me write it. It is not yes, it is test. So it may be possible that the entire one comes in the training data set and entire y, the value of entire y, which is the value 0, that means the normal people, that comes in the testing set. It may be possible such type of scenario may occur. Stratify is equal to y indicates that it will divided the uniformly, 1 and 0, both the values will be distributed uniformly in the y train and y test. Okay, now I'll use the random state is equal to 2. What is the significance of random state is equal to 2? Random state is equal to, it's just a notation. You can use the random state is equal to 3, 4 as well. But if you use the random state is equal to 3, or if you use random state is equal to 4, in that case, the entire data set will not match with my answer. That means your data set will be divided in a different way from my data set. Okay. So let's run it. Now check it. Extern print x shape extern shape x test shape. Here I am trying to show how the data are divided into the training set as well as the testing set. So let's run it. Total 303 data are available into the X. Among those 303 data, under X train, it has come 272 data, and under Y test, it's 31 data. Okay. Now I'm using LR. I'm just taking one variable for the logistic regression. You can put the other name as well. You can put the IT world with Animesh, that name as well. I'm talking about that things. That means LR. I'm taking it variable LR. You can take it other variable as well. Okay. Logistic regression. So let's run it. Now I'll take the training data for both the cases, that means X train and Y train, to fit the total model. So in that case, I will use lr.fit. That means here we are going to fitting the training data into the model. X train, comma, Y train. Let's run it. Now I will predict in terms of training data. Later again, I will predict in terms of testing data. I will explain why we are going to predict both the cases. That means in terms of training data and in terms of testing data. I will explain it later. So predict train is equal to lr dot predict. We are taking the X train. That means with the help of X train data, we are predicting something, and we know that Y train is the true value. So let's run it. So we get the prediction based on the train data. Now we are checking the accuracy. Score based on training. So I'll use accuracy score, which I have already imported from sklearn.matrix. From that module, matrix is the module and sklearn is the library. So accuracy score, it's a prediction trend. That means it was the prediction value, comma, Y trend. Y trend was the true value. Okay, let's run it. Now you will get the value. So accuracy based on training data is 84%. Okay, now we'll do the same thing, but in this case we'll measure the accuracy based on the testing data, and the later I will say why I am using both the cases. That means the prediction based on the training data as well as prediction based on the testing data. I'll explain that thing as well. So let me just copy it. Again, copy it, this line. Make some changes. Here I'm writing test. Here again I'm writing test. Accuracy based on test. Here I will write test. Here I will write test. So let's run it. Now you will see the value of the accuracy score based on test. Here the value is 77%. Okay, so accuracy based on training is 84%, and accuracy based on test, it's a 77%. So both the cases we have seen that accuracy is almost same, 84% and 77%. The training as well as the testing simultaneously. So we can say that our model is not under what we have designed. Our model is not under the overfitting or underfitting scenario. If the training accuracy based on the training data was higher, but accuracy based on the testing data is lower, in that scenario, we'll say that the model is overfitting. And if the opposite scenario occurs, like accuracy score based on the training data is less, but accuracy score based on the testing data is high, in that case, we will say that the model is underfitting. So to check that thing, that the model is underfitting or overfitting, we will use both the cases. That means we will predict the accuracy, we will observe the accuracy for both the cases, training as well as the testing. So we are getting quite high accuracy. If accuracy is more than 75%, so in that case, always we'll say that the model is good. So this was all about for today's tutorial. Thank you.